There are more stars in the observable universe than grains of sand on every beach on Earth, and many of them are billions of years older than our Sun. By every reasonable estimate, the galaxy should be crowded with civilizations. And yet, when we point our instruments at the sky and listen, we hear absolutely nothing. One physicist summed up the mystery over lunch, in 4 words: where is everybody? This is the Fermi Paradox. Where is everybody? The full story. Chapter 1. The question at lunch. The most famous question in the search for alien life was not asked in an observatory or a lecture hall. It was blurted out over lunch. One summer day in 1950, the Italian physicist Enrico Fermi, one of the architects of the atomic age, was walking to the Fuller Lodge at the Los Alamos Laboratory in New Mexico with 3 colleagues, Edward Teller, Herbert York, and Emil Konopinski. On the way, they had been joking about a recent New Yorker cartoon that blamed a rash of missing city trash cans on little green men from flying saucers. The conversation drifted on to other topics, and the group sat down to eat. Then, seemingly out of nowhere, Fermi suddenly asked a question that would carry his name for the next 70 years. His colleagues remembered the exact wording slightly differently, some recalling "where is everybody," others "don't you ever wonder where everybody is," but the meaning was unmistakable. Teller later recalled that the whole table burst out laughing, because despite the question arriving completely out of the blue, everyone instantly understood that Fermi was talking about extraterrestrial life. What made the offhand remark so powerful was the simple arithmetic hiding behind it. Fermi was famous for rough back-of-the-envelope calculations, and he could see the tension immediately. The galaxy is unimaginably old and unimaginably vast. If even a tiny fraction of its stars host planets, and a tiny fraction of those planets grow life, and a tiny fraction of that life becomes intelligent and technological, the numbers still add up to a galaxy that should be teeming with civilizations. So the emptiness he pointed at was not a minor puzzle. It was a genuine contradiction between what we expect and what we see. Chapter 2. A universe with room to spare. To feel the weight of Fermi's question, you have to grasp the numbers. Our Milky Way alone holds somewhere between 200 and 400 billion stars. The observable universe contains perhaps 2 trillion galaxies, adding up to an estimated 70 sextillion stars, a 7 followed by 22 zeros. Crucially, our Sun is a relative newcomer. Many stars in the galaxy formed billions of years before it, which means any civilizations around them could have a head start on us measured not in centuries, but in billions of years. It helps to make that head start concrete. Humanity broadcast its first radio waves barely more than a century ago, and went from those first crackling signals to landing machines on other planets within a single human lifetime. Now imagine a civilization that reached our level not 100 years ago, but 100,000, or 10 million years before us. The gap in capability would be almost impossible to describe. Their technology might look less like engineering and more like magic, or even like nature itself. Against the backdrop of deep cosmic time, we are not merely latecomers. We are infants who only just started paying attention. In 1961, the astronomer Frank Drake tried to turn this intuition into an actual equation. The Drake equation strings together 7 factors: how often stars form, how many have planets, how many of those planets could support life, how often life actually appears, how often it becomes intelligent, how often that intelligence builds signaling technology, and how long such civilizations last. Multiply them together and you get an estimate for the number of detectable civilizations in our galaxy right now. For decades, plugging in optimistic guesses gave answers comfortably greater than 1, often thousands. The equation has a fatal weakness, though, and Drake knew it. The first few terms we can now measure fairly well. Thanks to space telescopes like Kepler, we have confirmed more than 5,000 planets beyond our solar system, and current models suggest the Milky Way could hold billions of potentially habitable worlds. But the last several terms, the odds that life begins, becomes intelligent, and survives, are almost completely unknown. Each is a guess spanning many orders of magnitude, which means the Drake equation can just as easily predict a crowded galaxy or an empty one, depending entirely on what you believe. Chapter 3. The Great Silence. Fermi's lunchtime remark stayed an informal puzzle until 1975, when the astronomer Michael Hart turned it into a serious scientific argument. Hart pointed to a stubborn observation he called Fact A: there are no intelligent beings from outer space on Earth right now. That sounds trivial, but Hart argued it is devastating. Given how old the galaxy is, he reasoned, if even one technological civilization had arisen long ago, it would have had more than enough time to spread from star to star and reach every corner of the galaxy, including our own solar system, long before humans ever evolved. The timescales involved are what make the silence so loud. Even using slow, realistic starships that never break the speed of light, estimates suggest a determined civilization could colonize the entire Milky Way in something like 5 to 50 million years. That may sound enormous, but against the galaxy's age of over 13 billion years, it is the blink of an eye. The physicist Frank Tipler sharpened the point by invoking self-replicating machines, sometimes called von Neumann probes, robotic explorers that build copies of themselves from raw material at each new star. A single such probe, endlessly copying itself and fanning outward, could in theory explore or even blanket a galaxy the size of the Milky Way in as little as 1 million years, and it would only take one civilization, anywhere, ever, to launch the first one. So the sky should not just contain distant radio signals. It should be physically full of someone else's machines, monuments, or ruins. Instead, we find nothing. No probes, no megastructures, no signals, no evidence of any kind. Scientists gave this crushing emptiness a name: the Great Silence. Before we move on to the next chapter, if you're enjoying this, please like the video, follow so you don't miss future videos, and turn on notifications. Chapter 4. Maybe we are alone. The proposed answers to Fermi's question fall into a few broad camps, and the first is the most unsettling: maybe the silence is real because there is almost no one else out there. Perhaps the leap from lifeless chemistry to living cells is staggeringly rare. Perhaps simple microbes are common, but the jump to complex, intelligent, tool-using life almost never happens. This idea, sometimes called the rare Earth hypothesis, suggests that the specific combination of conditions that produced us, a stable star, a protective giant planet, a large moon, plate tectonics, is so unlikely that technological life may be nearly unique. In the late 1990s, the economist Robin Hanson gave this reasoning a chilling name: the Great Filter. The idea is that somewhere along the vast road from dead matter to a galaxy-spanning civilization, there is at least one step so improbable that almost nothing makes it through. The critical question is where that filter sits. If it lies behind us, in some early evolutionary hurdle we already cleared by sheer luck, then we may be among the first, and the future is ours to claim. That would be the good news version of cosmic loneliness. It is worth asking what such a filter could actually be. Look back along our own history, and the candidates are genuinely unnerving. The very origin of life, the moment lifeless chemistry first began to copy itself, may be a fluke almost never repeated anywhere. The leap from simple cells to complex ones took our planet billions of years and, as far as we can tell, happened just once. Any of these could be the improbable step that quietly stops most worlds cold. The truly frightening alternative is that every one of those hurdles was easy, and the real filter still lies ahead of every civilization, waiting somewhere near the point we ourselves have just reached. In 2018, 3 researchers at Oxford, Anders Sandberg, Eric Drexler, and Toby Ord, argued that the paradox may partly dissolve on its own. They pointed out that the Drake equation is usually fed single best-guess numbers, when in truth several of its terms carry uncertainty spanning dozens of orders of magnitude. When you honestly account for that uncertainty instead of hiding it, they showed, there is a substantial chance that humanity is simply alone in the observable universe. In that reading, the silence is not a paradox demanding an exotic explanation. It is exactly what an empty universe would sound like. Chapter 5. Maybe they are hiding. The second camp accepts that others may be out there, but argues we would not necessarily know it. One famous idea is the zoo hypothesis, proposed by the researcher John Ball in the early 1970s, which suggests advanced civilizations deliberately leave us alone, observing our development from a distance the way we watch animals in a nature reserve, careful not to interfere. A darker cousin of this idea was popularized by the science fiction writer Liu Cixin, The Dark Forest. In that grim picture, every civilization stays silent on purpose, because announcing your location to an unknown universe is simply too dangerous. Others suspect we are looking for the wrong signs entirely. In 1964, the Soviet astronomer Nikolai Kardashev proposed a scale ranking civilizations by the energy they command, a Type 1 harnessing a whole planet, a Type 2 a whole star, a Type 3 an entire galaxy. A civilization that advanced might build a Dyson sphere, a concept from physicist Freeman Dyson in 1960, a vast swarm of structures wrapped around a star to capture its energy, glowing in waste heat we could detect. Yet direct surveys of thousands upon thousands of galaxies have turned up no clear sign of any such artificial construction, anywhere. There is also the humbling possibility that the signals are all around us and we simply cannot read them. We have only been capable of listening for about 60 years, across a narrow band of frequencies, aimed at a tiny fraction of the sky. Searching for one specific alien broadcast this way has been compared to dipping a single glass of water from the ocean and concluding there are no fish in the sea. Worse still, a civilization millions of years ahead might communicate in ways we have not begun to imagine, its technology so advanced it would be indistinguishable from natural physics we do not yet understand. In that case, the silence would not mean absence at all. It would mean we are surrounded by a conversation we lack the senses to hear. And then there are the gentler explanations, rooted in space and time. The galaxy is so mind-bendingly large that two civilizations could rise and fall thousands of light-years apart and never overlap. A signal broadcast a million years ago may have already washed past a silent Earth. Radio technology may be a brief phase every civilization passes through and abandons. Or, most soberingly, technological societies may simply not last very long, destroying themselves through war, climate collapse, or their own runaway inventions before they ever manage to reach out and touch the stars. Chapter 6. Listening. Faced with a silence this deep, humanity did the only thing it could, it started actively listening. In 1960, the astronomer Frank Drake pointed a radio telescope in West Virginia at two nearby sun-like stars and swept for artificial signals, a project he called OSMA. It marked the birth of the modern search for extraterrestrial intelligence, known as SETI. For over 60 years since, scientists have scanned the sky across countless frequencies, hunting for a single broadcast that could not be explained by any natural process. For the most part, the results have been a long, unbroken quiet. There was one tantalizing exception. On August 15, 1977, a radio telescope in Ohio picked up a powerful, narrow burst of radio energy from the direction of the constellation Sagittarius. It lasted 72 seconds and matched almost everything researchers expected an alien signal to look like. The astronomer reviewing the printout was so startled he scrawled a single word beside the numbers: "Wow." The wow signal became legendary. But despite decades of searching, it has never appeared again, and to this day no one can say for certain what it was. The search is now larger and sharper than ever. In 2015, an initiative called Breakthrough Listen began a 10-year, $100 million campaign, using the world's biggest radio telescopes to scan millions of stars in unprecedented detail. At the same time, the explosion in exoplanet discoveries has transformed the debate. When Fermi asked his question, we did not know of a single planet beyond our solar system. Now we know the galaxy is packed with them. Every new world we find that could, in principle, host life makes the surrounding silence just a little more puzzling. Here is what makes the Fermi Paradox unlike any other mystery: there is no comforting answer. If we are truly alone, then the great filter lies behind us, and this fragile blue planet may be the only place in the entire cosmos where matter ever woke up and wondered about itself. But if the galaxy really is full of life, then the filter may lie ahead of us, a hurdle every civilization hits and fails, and our own silence might be a warning we are too young to read. Either possibility should stop us cold. The universe's greatest blind spot is not something we can point a telescope at. It is the deafening absence of everyone we were so sure would be there. So the next time you stand under a clear night sky, remember that every point of light up there is an unanswered question. We have the numbers that say the galaxy should be alive with voices, and we have a silence that refuses to explain itself. Maybe we are the first. Maybe we are being watched. Maybe we are simply not listening in the right way, at the right time. But until that silence breaks, the most honest answer to Fermi's question remains the one that has haunted us for over 70 years. We still do not know where everybody is. Space keeps its best secrets in plain sight. Follow Cosmic Blindspot and start seeing what everyone else misses.